Hello, in this video we'll show a polynomial regression with no degree of freedom. Here we have a Maclaurin expansion of a geometric series 1 over 1 minus x. We'll generate the dataset, which is equal to array formula 1 over 1, 1 minus x values. And we'll insert this. We'll show the chart for this. Insert the chart. And you use scatter chart. And show the trend line equation, which is polynomial raised to the power 8, because we will have 0 degrees of freedom. That's 8 degrees, and we will also show the equation. And the r squared would be 1, perfect 1.
Twin.
We can also show the expansion. Our expansion is y equals x to the power n, which is 1 plus x squared plus x cubed plus x to the power n, where our values of n start from 0 to infinity. But in this case, we'll just put it to the length of the data set. Our coefficient will all be 1. So our expansion will be array formula series sum of the x values raised to the power 0 and incremented by 1, because our n is 0 to 1, 2, 3. So incremented by 1, and our coefficients all will be 1. Our expansion almost matched to our uh, geometric series, our series. We will insert this to the chart. So we will add this to the chart. The series. You notice the red dots or the data set of the expansion are on the same line, on the same points, because they're almost the same, almost equal. So we will also show the trend line, polynomial to the power 8 or degree 8. So we'll show the equation and r squared. But there's a big difference here, because the coefficients of the expansion are all 1. This happens when you have no degree of freedom. You will not have the same coefficients. So we will calculate these coefficients using Linest. To do that, we will use the 1 comma x matrix in the Linest. So we'll have the Linest, the 1 comma x matrix. So our x will be raised to the power, we will have a column for x to the 0, x to the 1, x squared, x cubed, and so on. So we will copy the powers, will be transpose of the n values up to 8. So we have x to the 0. So this is array formula of the x values raised to the power 0. So we have the column for the 1 column, or x to the 0 column. We will copy this formula to the rest of the columns, but we'll have to lock the references. Now that we have locked the references, we now enter the x column. This is the x column, which matches to our x values of x. And this will be the x squared column. We have 8 squared is 0.64. 0.8 squared is 0.64. Then the x cubed column. X to the fourth column x to the fifth column, x to the sixth column, x to the seventh column, and x to the eighth column. Now we can enter the linest. So we have for the data set of the geometric series will be linest of data y and data x. And we'll show the full statistics. So our standard, the errors are 0. Our B0, is 1. Our B1 is 0.992. Our B2 is 0.992. Our B3 and B4 is 1.27. And our B5 and B6 is negative 1.08. 1.07 here, rounded was 1.08. And B7 and B8 is 5.38. Next, we regress the expansion, which is again linest data y and data x, and we show the full statistics. So our data y should be this range. So you'll notice our coefficients are all 1. This happens when there's no degree of freedom. So it's, if the degrees of freedom is 1 or 2 greater than 0, then these values here will be the same as these values here. But because there's no degree of freedom, the output of the linest, the coefficient will all be 1. So this explains what happens when there is no degree of freedom. The coefficients of the expansion, the regression coefficients of the expansion will all be 1.